Testing. Welcome to Dialogues. Just testing our audio. Testing, testing. Can you hear me?
Sarah, are you there? No.
I am. I just turned off my video because I'm the only
Okay,
one
just
on
a
screen. Yeah, go ahead.
quick question. You're going to introduce everybody. Do you want us to say hello? Thank you for that
I
kind. Do you want us to acknowledge that or just
Yeah,
sit
if
and
you feel comfortable, yeah, that would be nice.
Sounds good. We'll do it, Sarah.
Thanks. Okay, we're going to get started. Good afternoon, everyone, and thank you for being here for another ICArEHB Dialogues. It's my pleasure to welcome you and introduce you to our three incredible speakers, each of whom brings a unique perspective on how we understand human behavior, technology, and the evolving relationship between the two. First, we have Dr. Vera Aldeias, a geoarchaeologist whose work focuses on decoding human behavior through the sedimentary signatures left behind in archaeological sites. Her research explores where Homo sapiens first evolved and how modern human traits developed over time. Dr. Aldeias is currently a coordinating researcher and group leader at ICArEHB, the Interdisciplinary Center for Archaeology and the Evolution of Human Behavior at the University of Algarve here in Faro. Before joining ICArEHB, she completed her PhD at the University of Pennsylvania in Earth and Environmental Sciences and worked as a researcher at the Max Planck Institute for Evolutionary Anthropology in Leipzig. Thank you, Vera, for joining us today.
Thank you, Sarah. It's a pleasure to be here.
We'll also hear from Dr. Steve Kuhn, a leading expert in Pleistocene hominin behavior. His work explores how early humans lived, adapted, and shared knowledge using clues from stone tools and information technologies. He's led field and lab research in Turkey, Italy, Serbia, China, Morocco, and elsewhere. His latest book, The Evolution of Paleolithic Technologies, challenges traditional linear models of technological progress, proposing instead a more dynamic view shaped by environment, biology, and social change. Dr. Kuhn is the Fred A. Richter Distinguished Professor at the University of Arizona's School of Anthropology. He holds a PhD and MA from the University of New Mexico and a BA from UC Santa Cruz. His many honors include a Humboldt Research Prize and recognition from the Society for American Archaeology for excellence in archaeological analysis. Welcome, Steve, and thanks for being here.
Thank you very much, and I'm happy to be here.
And finally, we're joined by Davi Rios, a computer scientist turned tech humanist. After earning his degree from the Federal University of Pernambuco in Brazil, Davi launched a car-sharing startup inspired by the traffic woes in his hometown. In 2011, he joined Google's search team, where he's been ever since, working to improve how we find information online. His work has led him to the ethical dilemmas of search functions, misinformation, and generative AI. Outside of tech, he co-founded CuidadoParaTodos.com, an open source platform that helps Brazilian doctors design picture-based prescriptions for patients with low literacy. Davi now lives in Switzerland, and when he's not dreaming up ways to restore forests, you'll find him cycling or playing samba with friends. Welcome, Davi. Thanks so much for joining us.
Thanks so much, Sarah. Really excited to be part of the dialogues today.
Well, we're in for an exciting and thought-provoking session, so let's get right to it. Our first topic today is, what do we even mean when we say technology? Vera, would you start us off?
Sure. So I think when we actually talk about technology, we are actually talking about two related but slightly different things. So on one hand, technology refers to the tools humans have used over time to get things done. It's a big part of how we've evolved. And this definition as technology as the tools people used is especially important in archaeology, particularly when we are dealing with prehistoric times, when we don't have writing. And you can see this relevance actually in the way we divide archaeological time in prehistory, like the Stone Age, the New Age or the Neolithic, the Iron Age, the Bronze Age, and so forth. So archaeologists really focus on the distinction of time based on the perceived main type of tool developed at each time period. So that's one way of thinking about technology. But on the other hand, we can also think of the term technology as meaning how we use today's technology to learn about the past, in our case, right? So this relates to how we go about digging up data from the past, studying the archaeological record. It's where modern technology comes in, actually, and we use all kinds of advancements to help us unearth and interpret this information. So in this slide, in this figure, you can actually see the vast array of techniques that we use in my field of research, geoarchaeology, to study the archaeological sediments and soils.
Thank you, Vera. Very informative. Now, Davi, I have a suspicion you might have a different answer to this question.
Yeah, Sarah. So before getting to my answer to the question, I like to say how much Vera's point that technology is such an important part of archaeology that this is how the field divides the archaeological time periods. This is really blew my mind. It's something that was like just there, but like had never occurred to me. I really found that super interesting. And back to the question, what is technology? So I am a computer science. So for my area, technology are tools that allow us to represent and manipulate information in the form of symbols. I think since the last century, we've had like digital technologies where information is represented using electronic signals. And this representation allows us to do this at a larger scale with less errors, like faster. So for example, here we have like a database representation, which is like a digital written on a physical form on a disk on an electronic SSD, for example. However, before digital, we also did computing with analogic tools, non-digital tools. Well, writing is one example, as well as like tools for managing time, like calendars. And one fun fact is that when I was applying for my Google software engineering job, one of the questions we were asked at the interview was about converting dates from Mayan to Gregorian calendar. So yeah, just to say as an example, that is really a technology that is timeless. All these technologies, they require us to define a language, a way to represent the symbols through which we can decode and process this information and retrieve this information. So the language itself is also a very important technology for us, computer science.
Thank you, Davi. Very interesting. Steve, would you tell us, what do you think of when we ask, what do you mean when we say technology?
Okay, well, I'm an archaeologist, so I have to step back and start from a broader definition, which focuses mainly on material culture, objects that are kind of the physical manifestation of technological knowledge. Ultimately, technology is knowledge, but it's physical. We experience it often through material culture. And from this perspective, technology is not a new thing at all. It's been around in various forms for millions of years. The earliest known artifacts of stone date to more than 3 million years ago, and human ancestors were probably making tools of other materials that didn't preserve for longer than that. But to return to Davi's perspective, technologies, we think of technologies, of information technology as being a very new thing, but technologies for storing and processing and broadcasting information go way back as well, to the times of the first Homo sapiens and the late Neanderthals. Things like art and ornamentation are things that people use to communicate through material means. So pigments, red ochre, shown in this slide, or shell beads were ways of broadcasting social information. They're early versions of Instagram or TikTok. They were ways of telling people at a distance who you are and what you're all about. Cave art, which is another kind of early technology, information technology, shown there's one of the earliest known, probably the earliest known figurative depictions of an animal from Indonesia, actually. That was probably also used in preserving and distributing information as parts of rituals and activities that ensured continuity and knowledge across generations. So we've had versions of information technology for a very long time as well.
Great, very interesting. Cave art as early Instagram is something I think we can all understand. So building off Stephen's points there, how has past technology helped us to understand prehistoric societies? Stephen, would you start us off?
Well, that's a big question, but for archaeologists, again, it's very important because that's when when people started making stone tools, for example, which is what I study more than 3 million years ago, it provided whole new perspectives on their behaviors. Prior to that, the only real information we have about early hominins comes from their skeletons, and we can learn a lot about that. But there's a limit to it. So, for example, human fossils, the skeletal remains are rare. They only preserve under a narrow range of circumstances. And these creatures probably weren't all that common on the landscape anyway. We don't find human fossils often, and we don't find them everywhere. Stone tools, on the other hand, once people started, or human ancestors started making them, are incredibly common and they preserve indefinitely. So once human ancestors were habitually doing this, habitually producing artifacts and leaving them littered around the landscape, they left traces themselves wherever they went. And we can begin to see where they went on the landscape, what places they preferred, what places they avoided, how far they ranged, and providing all kinds of insights into their ecology that we couldn't really get from other sources. Another source of insight has to do with the cognitive processes, the intellectual machinations that go into making stone tools. The first ones, the earliest ones, like in this picture here, are pretty simple to make. Although they do require some knowledge and maybe even some training. There's debate about that. But over time, procedures and techniques for making artifacts become much more complicated. And as we study this complication, it provides insights into the thought processes, into the reasoning, into the kinds of choices that our ancestors made at different times in the past. Basically, it tells us a little bit about what they were doing with those increasingly large brains that they have.
Great, thank you very much. Vera, how has technology helped you understand prehistoric societies in your research? I imagine it's a bit different.
Sure. So if we think about technology for me in my research, I'm actually particularly interested in how humans became the obligated fire users that we are today. Like this photo here of sun hunter-gatherers from Southern Africa is just an example of how dependent we are on fire. So the ways we use and control fire are really, I think, among the major technological leaps that we associate with humans. And actually, the degree to which we can manipulate fire really distinguishes us from other animals, right? So I am interested in how pyrotechnology, the technology of fire, has actually shaped our evolution. So typically Neanderthals would focus on the origins of fire use, right? When and where did our ancestors started to use fire, which I think is super interesting. But actually beyond this first off, I'm actually interested in understanding how pyrotechnology has changed through time and space, like other technologies. So for example, my colleagues Davi have shown these peculiar patterns of periods where we do not have widespread evidence for fire use. And first, we show this in association with Neanderthals during glacial times in 2 sites in Southwest France, where we do have Neanderthal occupations during glacial periods, but we lack evidence for a widespread presence of fire during these occupations, which is interesting. And I think it means that during these glacial periods, there is possibility that past humans had a different way of coping with the cold, that is not just the use of fire, which I think is very intriguing for us. But another way I think about the evolution of pyrotechnology is this recent review that we did on early modern humans, so our species within Europe. So here we also notice something interesting. So there seems to be a shift in the types of fire use. Like in this graph, you can see different types of hearths, like campfires you would see. So a flat hearth, or a hearth you do in a pitch, or a hearth that you put a base and then do the fire on top, or more complex kind of structures like kilns. And the first thing you see here is that at certain times, there's a clear variety, right? There are different types of structures being used by modern humans in Europe. There seems to be a shift in the types of fire used through time. So that's interesting, right? Technology is changing. But I think what was really also striking, though, is how little solid published data we have on our species, modern humans, using fire during extreme cold periods. Like, for instance, in this case, what we saw is that during the last glacial maximum, which is a period of really harsh cold conditions, roughly between 26 and 19,000 years ago, we really don't have much evidence for fire. which I think for me sparks my imagination, because this difference with different uses of presence and absence of types of technology are very different from our expectations. And I think we can really deeply inform us understanding prehistoric societies if we dig into it.
Yeah, definitely. Thank you, Vera. Very interesting. Now, Davi, I realize you don't study prehistoric societies, but maybe you've run into, at another interview, perhaps some ideas about how technology has helped us understand the past.
Hi, Sarah. Yeah, that's right. I do. While I do not study prehistorical societies, I am very interested on like how people do this, as you mentioned, computing without computers before digital. A well-known example we study in school is the abacus. Like people use this to sum and count. One example that I find super interesting, though, that is related, is the quipus from the Incas, from the populations from the Andes. Uh, they were a system that the Incas used to store information in the form of knots on series of strings that are like usually made from cotton. This will be the analog equivalent of like a complicated spreadsheet, or for us computer scientists, more like a graph database. And we have been able to decipher some quipus, and we know now that their knots and the types of knots and their position on the string represent numbers in the decimal system. So like a spreadsheet, like an abacus. Um, However, we also know that the Incas used many other dimensions for storing information on a quipu. Like they used color, the plying direction of the chords, how each chord is attached to the main chord, as well as secondary and tertiary chords, which remind me of the graph we had for the database, like with connected pages. Um, we do not fully know today what all these quipus mean. Like do not know how to decipher them, but we do know from Spanish colonizers' accounts that some of them contained much more than numbers, like stories, maps, or family histories. I find that super interesting and a very like physical manifestation of like a complicated computing concept that we use today, like crafts, and how they use this for processing and storing information for years. I found a super interesting example.
It definitely is. Thank you, Davi, for sharing that with us. Let's move on to the next question, which is a bit more in your wheelhouse. What technological advances are reshaping your discipline? And I'm first going to ask Vera to tell us about this, because I know it's a key part of her ongoing research at ICArEHB.
Yes, sure. So for me, I think really one of the most exciting technological breakthroughs that is really changing the way we can study and understand the past is the ability to extract ancient DNA directly from archaeological sediments. So like Steve said, it's very rare for Earth archaeologists to find human fossils, but sediments, we have them. They are everywhere. So they actually make up most of what we have from the past, what we dig up as archaeologists. So really being able to get information about ancient humans and population changes from the sediments itself, I think is a game changer. I'm not a geneticist, but in my current research as a geoarchaeologist, I'm working with geneticist colleagues to explore these kind of questions. So we are interested in figuring out not just how to extract it that we know, but actually to understand where and how DNA is actually preserved in sediments. There's still a lot we don't know, so that's super exciting, but we don't know whether DNA can move around in a soil. So more recent DNA would now be in an older time period or the opposite, or we don't know where actually to target, right? Which hotspots, which mineral or particles give us the best chance of recovering ancient DNA. So I think we have a lot of interesting data coming out from studies on sedimentary ancient DNA in the near future, and I think that's very exciting.
It's definitely very exciting. Thank you, Vera. Steve, how has technological advances reshaped your discipline?
There are I like to take it back to the beginning. The invention of the shovel and the bucket really changed archaeology. Before that, we couldn't do anything. But to bring it to more recent times, I can think of a couple examples. One, the first one very close to Vera's heart, um, on-site geochemistry. In the stereotype of archaeologists is that they excavate, they discover things buried in dirt. And so for much of the history of the discipline, the dirt, and sorry, Vera, more properly sediment, was something you removed. You got rid of it to get at the stuff you really wanted, which was the potsherds and the bones and the stones and so forth. But in the late 1980s, a group of researchers began to ask whether you could learn more from the sediment itself. They took advantage of some advances in instrumentation to bring tools like portable mass spectrometers into the field. And there's a picture of the first iteration of this on the left, to analyze sediments in real time as they were removed from the ground. And it completely changed our view on the stuff we dug through, that we were moving in order to expose the archaeology. It showed us that the sediments were part of the archaeology, and also that our naked eye observations, what we thought we could read from just looking at a profile, a vertical cut through sediments, was often misleading. And there was a lot more to learn about human behavior from the dirt that enclosed the finds than we had realized. So that picture in the middle, which appears to show these sort of brown and white and black stripes, we might read that, and we did read those kinds of things before as, okay, there's a series of fireplaces. The black is charcoal, the white is ash, and the brown is just dirt. Well, it turns out sometimes the white is ash, but sometimes it's decayed guano or manure from birds or bats. The brown stuff is not just dirt, sometimes it's ash that's been altered chemically. And there's a lot more ash in that deposit than you would think just to stare at it. Now, there's another area where technology is really causing major changes in the field, and that's remote sensing. Getting imagery from satellites, getting imagery from airplanes, especially technologies like LiDAR, which is sort of like radar but with light. It's completely changing our impression of archaeological and cultural landscapes. For example, these are some structures. This comes from the work of two of my colleagues here in Arizona, Professor Takeshi Inamata and Professor Daniela Triadon, who are working on early Maya monuments in southern Mexico and Guatemala. And with LiDAR imagery from above, they're able to show that there are enormous monuments. You can see the scale on the right. That's a kind of rectangular platform that's more than 1 kilometer long, but it's only a few meters high. And on the ground, you don't really see it. You don't know, or you see it, but you can't recognize it as something that's cultural. But from the air and from using the LiDAR technology, you see that entire area is full of human constructed features. And it's showing that people had modified the landscape in ways and at scales that was completely unimaginable before. So it's really changing how archaeologists are perceiving these cultures and the landscapes that they created and occupied.
Thank you, Stephen. Great answer from the micro to the macro. Now, Davi, I know you're going to have a lot to say regarding this question. So tell us, what technological advances are shaping your discipline?
So I think it's what's in everyone's mind lately. Recently, like we had a large technology leap in computer science in general, with the development of the so-called deep learning models, also called the LLMs, the large language models, which enable many advancements like these new generative AI tools that like everyone is using lately. These tools are very revolutionary for us, especially because of their abilities to understand text they started, like the technology behind this change, are evolutions of what we had in the past called neural networks. They are actually quite old ideas that lay dormant for years without much investment, without much research on them. And they were originally inspired by how the brain works, with neurons activating each other, like you have here on the image. They are very powerful for their ability to learn nonlinear relationships. So it was amazing when we started using this technology. But since the model ends up quite complicated and hard to understand, they weren't very popular for many years. Two things were crucial for their rebirth recently. First, the large availability of training data. And now we have like the internet with many images, with text, and also the availability of more powerful machines capable of processing these large data sets. Also, we learned how to make these programs work on distributed systems, which was something we couldn't do before. And this allowed a whole new gains of scale, like in many orders of magnitude. Here on the image, we see the architecture of the, for us, it's very famous LeNet, developed by Jan LeCun, one of the fathers of the modern machine learning. So this system was used in the late 90s for doing optical character recognition to read checks that people were using on US banks and zip codes on the postal service. And then finally, in 2017, after a lot of research on this topic, a team of Google engineers published this seminal article called Attention is All You Need, which has this diagram that you see on the left. With whole new ideas on how the network, this neural network, uses context to make inferences. This so-called transformer architecture is the main technology behind the major chatbots currently available on the market that are really changing how we work. And specifically to my work on Google search, like we have refined for the last like 25 years, many algorithms that try to match the words on the user query to the words on the web page. And in most cases, it works really well, but it often fails in ways that seem like actually kind of stupid to the user when the context where a word appears makes a lot of difference. So these are cases where these tools really shine because they can understand this context really well. And one example from my work is that until recently, I was working on a team that tried to detect whether a given text contained derogatory or hateful content towards protected groups. And this was really hard to do based only on the words on the page. And the LLMs, the large language models, they are much better at considering the whole context of the page. And this unlocked like amazing wins for us in this area. And it's also very amazing because these tools are like available for everyone and like part of everyone's workflows now. So this is a large revolution at the moment.
Definitely. Thank you, Davi. So what I'm getting from all of your answers is that you're all techno optimists. Are there not any downsides? Davi, you must know some downsides.
I actually have a few questions on this topic for the archaeologists. One question that I have is like, how will we be able to study and revisit the past once it's no longer in physical form? Now that we do, most humans are leaving most traces online in digital form, and digital is not only volatile, but it also easier to rewrite. So how do we go back and study this past that we're living now?
Great question. Steve, do you have an answer at hand?
Actually, so I think people are certainly engaged with this question. There are a number of independent efforts to use online or digital data to create grand archaeological syntheses, to take large amounts of data that are out there in various forms and use them to fulfill the field's promise to provide deep histories of humanity that are relevant to the contemporary world. I think, for example, has one of these initiatives. So as a field, people see the possibilities, even if they haven't fully realized them as yet. But at the same time, in recognizing this potential, there's also recognition of there are drawbacks, or at least there are obstacles. And the main one is you can only synthesize data, and this speaks directly to Davi's question. You can only synthesize data that people chose to collect. And there's a great example coming from much earlier, from the pre-digital era, which is the study of European cave art. As many people know, they're in parts of particularly southwestern Europe. There's this fantastic cave art, these beautiful paintings and engravings on the walls of caves. And they've been of interest. They've engaged scholars for more than a century. But a lot of them are really hard to access. They're in deep caves. They're places you have to crawl into. You have to have special equipment to see them. And for many decades, only a few intrepid researchers would actually take the trouble and, deal with the risk of actually crawling into these places to see these images. And people like the Abbé Roy, who is a French pioneer in this kind of study, would undergo the risk to basically crawl into caves and document these paintings, which he did at the time. The photography really wasn't up to the task. And so he would go in and do painting. He would do rubbings and watercolors of the cave art. And then he brought it out and he published it. Well, there were lots and lots of scholars who were interested in cave art, but they couldn't or didn't take the trouble to actually see it directly. And they just studied the Abbé Roy's watercolors. And of course, these images were highly interpreted. They incorporated the biases that he had as an observer, and so forth. And so for many years, people were making deep interpretations of what were basically the biases of the observers who actually went in and did these watercolors of the cave art. And I think the broader lesson is that we have to do the archaeology of the digital record. We have to understand how it was collected, who collected it, why they collected it, what they chose to collect, and what they ignored. It's the only way to understand the strengths and the weaknesses and the blind spots in this vast amount of information that the field has amassed over the past couple of centuries.
So it's a new form of the archaeology of archaeologists. Thanks, Steve. Vera, I'm sure you have an example of that type of thing.
Yeah, for sure. I think we have several examples of having to do the archaeology of the archaeologists, right? So, for instance, in the site of La Ferracie, which site in France, it's a super important site in southwest France that was excavated a long time ago. It actually was started to be excavated in the beginning of the 20th century. So this site is also important because several of these very rare Neanderthal skeletons were found early on. And finding such skeletons is something super important. As you can see from the photographs here, the excavators in the beginning of the 20th century actually did a wonderful job at times of taking pictures, which is not as easy as today, right? And here you see photos of attaching a bone of this Neanderthal skeleton with roughly the area where it was discovered from, right? So in one photo, you see a person with a little box showing where the bone is, and then there's a close-up of the bone with the strings to say, hey, we found it here, which I think is phenomenal. But it is archaeology of the archaeologists, because you can imagine when we go back to the site now and we try to understand where was this, right? What was the context? What was the layer that this fossil was found is really hard to assess based on a black and white photograph. So I agree, we are really biased by the type of information that we have. And in this case, from older excavations, we are always trying to redo where was it found.
Definitely. Thanks, Vera. Davi, do you have anything you want to add to this conversation about the downsides of new technologies?
Yeah, of course. Steve brings an interesting point about how biases can hide like in large data sets. We have definitely seen this very often in modern computer science, especially now that we have the power and the technology to analyze these sets. And in the beginning, we really thought that since we like sampled uniformly from the real world, from a uniform distribution, this would give us a fair representation of our source. However, we quickly noticed that the distribution gets much noisier on the so-called long tail, and this really affected the performance of the product. So here we have like two examples. On the left, I think it's a facial recognition program from Microsoft, if I'm not mistaken, which performed really badly on darker faces, especially darker female faces. And this was like a byproduct of the fact that this class was underrepresented on their training data. On the right, you have from my work, we have an example query that we looked for many times. That is, when you search for unprofessional versus professional hair, you get a very different types of demographics on both results. So for unprofessional hair, you get like people with darker skins, and for professional hair, you get people with lighter skin. And this is also an effect of the distribution of these terms on the web and how we process these signals, and just an effect of how this noise on the long tail puts us away from the goals of the product itself. This required us to build whole new tools to analyze our training sets, our own archaeology of the data set, if you will, and make sure that this really matched our expected distributions, even on these slices. And tracking this is still today one of the most complex parts of building these large machine learning systems, definitely.
Very interesting. Thank you, Davi. So it's a problem for all of us, unfortunately. Okay, so staying on this theme, the next question we're going to address, what are the ethical implications of these new technologies? And let's just start right off with you, Davi. I'm sure you have this at the front of your mind.
Yeah, this is something we think all the time. I mean, we're building these products, we're putting them to the world, and we need to be mindful of their ethical implications, of course. One of the we just saw on the previous slide, like who gets to be responsible by the output of these models. Like as more people turn to the LLMs as sources of information, how their makers get to be liable for their errors. Like how do people interpret these errors? There's a big discussion being had right now about the scraping of the training data. So these models, they are trained on data that we use from they read from the web, and they learn how to imitate the style or the way some people write, the way some people draw. Here we have some example from a very interesting blog post from this artist called Sara E. On the left, you see her own drawing, and on the right, you see a drawing that it was imitated by Stable Diffusion. You can go to, I think this model is like 2 or 3 years old now. But like you could go there and ask like, give me a cartoon on the style of Sara E, and it just gives you. And this brings lots of important questions about copyright and being able to imitate an artist's work. There's a very important conversation to be had too about the labeling work. So all these models, they require people to provide them with training data. So we need to you need to look at the responses and be able to say this is not a good response according to this policy or this other policy. And this is usually work that is done by hiring cheap labor on some other countries usually. And this is a very old, even previous to LLMs actually. People would do this for content moderation especially. And now that we need to curate the inputs for machine learning model training, this became an even larger problem. And finally, I think one of the larger discussion that is already becoming a big problem is for the energy use that these language models require. For like we had decades of improvements in energy efficiency for data centers, and now we are wholly changing the technology that we are hosting on these data centers, and for something that is a lot more energy intensive. So we are actually like looking into reviving old nuclear power plants, for example, to power these data centers. They are being moved to countries where energy is cheaper, and so there's a lots of shifting ground due to this part of energy use. And this affects also, of course, the carbon emissions, like the water consumption, the natural resources consumption from these data centers is bound to increase because of this, because of how we are using these new technologies. And well, they are becoming scarce, like they are not as plentiful as they were.
Definitely, those are some scary scary setbacks to using ChatGPT to write your email for you. Stephen, how about in your use of technology? Have you run into some ethical implications?
Well, I can tell you right now, I'm a little bit in shock about the energy cost, and I think next time I decide to ask an AI to, generate me a picture of a Neanderthal playing an electric guitar, I'm going to think twice about it because it uses more energy than I do in a week otherwise. Yeah, I can return to this topic of remote sensing. These grand overviews of landscapes that are provided by satellite or LiDAR imagery. There's been a sort of general idea that digital data democratizes things, that you reduce every information to ones and zeros and everybody can access it. And that in principle is true. Of course, it's not always realized that, for example, access to things like satellite data is limited to individuals or groups that can afford it, that have the right security clearances sometimes, and things like that. But as people dive into this, as they start to apply these technologies, and here I'm really talking about other colleagues, not myself, because I don't necessarily use this technology in my work. But when people are working with indigenous communities, they find that this omniscient perspective offered by a satellite or a LiDAR overflight, an airplane flying over an area and taking LiDAR imagery, can cut in two different directions and can appear very different to different communities. So some indigenous communities participate enthusiastically in mapping projects and attempts to understand the landscape using this kind of imagery, where especially groups that had sort of indigenous mapping, where mapping was something that they engaged in even before this. And they're really into it. They like it a lot. But other groups are more circumspect about it. And in many cases, your access to the landscape, your understanding of the landscape depends a lot on who you are, your age, your gender, your tribal affiliations, and so forth. And parts of the landscape are really off limits to people who don't have the right identity to understand it or to participate in it. Maybe they just shouldn't be there. Maybe it's dangerous to them. Whereas this omniscient view from above, from an airplane or a satellite, kind of violates these principles because everyone can see everything. And so some groups, some communities are very wary of this because it their landscape is structured so that some people should see certain things and other people should see other things. And there are parts of the landscape where certain people and certainly outsiders shouldn't go. And yet this kind of violates it. Now, to say this is a problem is also to recognize that there are scholars and indigenous peoples actively trying to work on this because they see the value in these technologies, but they want to make them work for the people on the ground too.
Yeah, great point, Steve. Thank you. Vera, what about in your work? Have you run into some ethical implications?
Yes. So, I mean, this photo that I put here is from my colleague Natalia Guez, and actually it shows archaeologists backfilling an excavation in a very windy day. But it also, I think for me, it really illustrates this wonderful way how archaeological excavations are by nature destructive, right? So once we dig something up, we cannot put it right back rightly in the way that it was, or recover the original arrangement of materials as it was. So when we excavate, we break up things. And I think that's especially important to remember because archaeology is not just like we talked about finding the artifacts, right? A huge amount of valuable information is actually preserved in the sediments themselves, as Stephen also mentioned. And I think this part is very ethically important for us to remember. We should, of course, excavate, but we have to remember that it's destructive and it's not repeatable. We cannot find another one. But I also think that there's some good parts, which is with the advancement of methods we now have, and I hope even more so with the ones we'll have in the future, I think we can really get a lot of insights from much smaller sample sizes. And so for me, I think large scale open area excavations are something we should think about it from the ethical perspective, because they are finite, they're a finite resource. So we cannot lose them. They're not for one archaeologist, but for all of us. And I think we should be thinking about preserving some of these large-scale areas of untouched parts of sites for future research. And I'm really thinking that I'm positive that we'll be able to learn much more about them in the future. So we have to think about the ethical considerations of excavating everything we can find.
Yeah, I definitely agree, Vera. Thank you for that point. And if you'll let me interject for just a moment, there's actually a famous site in southwestern Germany where I did my PhD called Vogelherd, which is a great example of this. So it was excavated in the 1930s by Gustav Rieck, who's a German archaeologist from the University of Tübingen. And when he did the excavations, he removed all the sediment, literally every last grain of sediment within that cave. He took out, and after removing artifacts from that sediment, he tossed it down the hill in the front of the cave, very similar to that image you just showed. Now, he did find a number of beautifully crafted ivory animal figurines, and there's one example on the slide. And these are some of the earliest figurative portable art in the world. But a more recent team excavated the back dirt, as we call it, so the dirt along the hill, and they actually found hundreds more fragments and in some cases complete figurines. So we have completely lost the context of all of those materials. And nowadays, with our advanced methods, we'd ask questions like, were the figurines buried at the site? Was it intentional? Were they broken before or after they were buried? But because Professor Rieck dug out all the sediment, we'll probably never have any answers to those questions, which is a shame.
That's a very great point, Sarah. I agree completely.
Thank you. Okay, so moving on to our last question, and it's a big one. How has technology shaped society and vice versa? Vera, can I start with you?
It is a big question for sure. So I think it's maybe worth reflecting on how we still tend to think about technology today. And I think a lot of our way of thinking is still shaped by these 19th century ideas that equate technological change with progress, right? Like this, linear way of marching, in this case, of course, always man. But history, I think, actually shows that this isn't always the case. It's not always this linearity for better and positive. And I've already mentioned there's some examples of fire technology that examples sometimes we lose some part of the technology or we find other ways to do it, or sometimes we gain it, etc. And sometimes there's more diversity. But another great example, and one that maybe Stephen is way more expert than I am, right, is stone tools. They were used for millions of years, but today they are completely unfamiliar to most of us. So when we as archaeologists, or more Stephen, as archaeologists that studies these stone tools, these lithics, actually what we have to do is to reverse engineer how they were made because the knowledge didn't actually survive into modern times. But I think there are several examples. Another example of how we can lose technology in more recent times is, for instance, the Roman cementum, the opus signinum, that Romans used to make areas watertight. Roman loved their baths, right? And this was widespread during Roman times, but actually I find it super interesting to know that we actually, until very recently, we did not know how to actually make this cement. And it's not that long ago that this technology was widespread. But the actual recipe is something that we actually had to rediscover since the original recipe was lost to us. So I think it's really that it's a big question, but this idea of linearity and once you have it, you always have it, I don't think it's that simple.
Very interesting. Thank you, Vera. Davi, I bet you have some examples of lost technologies or, yeah.
Yeah. Vera's example of lost technology of stone tools reminds me of how a lots of software that powers the world today was written on very old programming languages that very few people today now know how to maintain. And learning them is today a very lucrative career. I don't know how that applies to stone tools too. Back to the question, I am more interested on the vice versa part, like how society influences the development of technology. Um, uh, I'm very curious to how people get to be the stewards of the evolution of this technology. How will we, as a society, be able to reap these benefits without letting them, for example, take too many resources or like still helping keep essential industries alive? And a lot of these discussions today are being held at the government level, especially here in Europe, where like privacy is a bigger concern. And but with ever major advance, people look again to technology, looking for like a salvation. We will be able to do nothing now, and robots will do everything for us. But history has shown that it rarely works like that. Like they are tools, they help us, they push us forward, but they are rarely a panacea that fixes all our issues.
Except maybe for vacuuming.
Yeah.
Stephen, what do you think about this point? Do you have some insights on technology and society and its relationship?
Oh, absolutely. I think, look, we are technological beings and we have been for a long time. It's had enormous influence on our societies and our biology even. In one way, the history of human technology can be seen as people sequentially turning more and more basic functions over to material or technological aids. So this graphic illustrates some of these. Probably the first one was the stone tool in the right middle, which was used. Early stone tools were probably used mostly in food acquisition and getting at kinds of foods that people couldn't access using their fingers and their teeth or human ancestry. So that they basically turned over some of these basic physical functions of getting food to stone tools. Later on, the development of fire, which Vera talked about, turned over other basic functions like thermoregulation and even aspects of digestion to a form of technology, which is controlled fire, that people use fire to alter foods in ways that their stomachs and intestines couldn't do it, and turn them into accessible foods. It also allowed people to live in places where They didn't have their bodies alone couldn't keep them warm. So things like writing and simple digital technology enhance or replace some of our basic mental functions relating to things like memory and arithmetic. And one of the real challenging things about AI, and one of the things that people, I think, see as an existential crisis, is that some people claim or worry that it can replace our most treasured and unique feature, which is our ability to imagine and create new things. That we basically worry that we're not going to be the only sapiens creature on the planet anymore. On the other hand, maybe that horse has already left the barn, and Vera, we've talked about this a little bit.
Yeah, we did. I think it's true, Stephen. But I would say that maybe like an important point here about that is that we now work on very interdisciplinary teams of different expertise. So I wonder if we have kind of outsourced our knowledge to each other, and that's not so bad.
Absolutely. If we can trust each other. Yeah, and something else that's worth pointing out is that for a lot of human history, technological change was very gradual, and its effects were probably undetectable to an individual. So that, when people, for example, first developed fire, it probably came in very gradually, and nobody said, "Oh, in my day, we could just stay warm by shivering, and now you kids need fire to stay warm." It happened, it happened over generations. Now technological change is very fast, and we can detect it within our lifetimes. So that, I don't know, I don't remember the first kind of telephone in this picture. Probably when I was a kid, the number 3 and from the left is the ones I remember. But all of that's happened in my lifetime, and I like to think I'm not that old. So we're seeing this happen within our lifetimes. And so we have these society-wide discussions about the wisdom of having certain technologies permeate our social and intellectual worlds, like questions about how important screens are to people. But it's also important and kind of comforting to remind people that this is not a new issue. So this is a quote from Plato, or one of Plato's dialogues, and he's putting the words in Socrates' mouth. We don't know if Socrates said this or not, but basically what he's saying is that writing down our ideas is going to really hurt humanity. We really need to, our ideas are most alive and most active when we're actually discussing them face to face. That writing down our ideas will cause a problem. It will implant forgetfulness in their souls. They'll cease to exercise memory because they rely on that which is written. In other words, Plato and Socrates are saying, writing could be the doom of human memory. Well, that was 2,400 years ago. I don't think human memory might well have changed with the widespread use of writing. But it certainly, we would hope, hasn't spelled the end of human intellectual life. So these are problems that people have wrestled with for a long time. What's nice is that society as a whole is aware of them. And so we as societies have the power to really talk about and hopefully influence how these technologies proliferate and over our lives or not. And people like Davi are helping to guide this.
Yeah, definitely. Thank you, Stephen. So just to sum it up, the image I'm getting, the feeling I'm getting from all of you are you're still techno optimists. It's still a good time to be a technological ape. Would you agree?
I would not say no to that.
Very much, yes.
Great.
The option is limited.
Very true. Well, thank you all for this wonderful dialogues and your insightful inputs. It's really been a great experience, and I'm sure our audience agrees. Now we're going to move to the question and answer period, and I'm happy to say we've already got a ton of questions coming in. The very first one I'm going to throw out there, I think this one's probably for Vera. Could people control fire before they knew how to make it? Vera, what do you think?
Well, we've looked a lot into this, right? Because some things don't preserve, so it's really hard to know for sure. But I think we have to think about it at several stages. So we can think about first being habituated to see fire and not freak out, right? And then probably to start, harvesting some of it because an animal was burned and you ate it or you transported it. And then I think it's at a later stage probably is when you can control it. So you harvest it and you can actually use it. And then starting a fire, right? Which for us is obvious. That probably is something that is not the first thing that happens. You cannot start and do this first spark. So that's something that I think it probably came after.
Great, thank you. This next question is a really interesting one. Could AI help us decode quipus better in the future? And Davi, I'm going to throw this to you.
That's a very interesting question. Like as I keep reading about quipus, I was thinking all the time, like maybe this is a problem we could like just throw machine learning into it and see what happens. So turns out these tools are very good at pattern matching, like how they are able to learn how concepts translate between languages and how they can learn this basically about learning positions on numbers, and it's very powerful. Uh, like people have had examples of let's have a large language model invent a new language, and it invents a language. Um, we should also remember that these models are also very prone to what you call hallucinations, also fabrications. Um, so for this specific problem, like if this is the problem we call in computer science grounding, like you should give something for the LLM to be based on. Like if you just let it answer, it will answer. You do not know how this applies to the real world. Um, so what I'm thinking is like, what could you provide to the model as grounding? Maybe the way we decoded the existing quipus that we know how they worked was like we matched them against documents from the Spanish colonizers. Like they had this document saying, "Oh, this person had, I don't know, 10 llamas," and then we had another quipu that had like, "Oh, so this is the 10," and so maybe this is one way we can do pattern matching at scale, like just give it a ton of documents from the Spanish colonizers and then ask them, how does this quipu match anything you've seen before? Maybe this is like, you archaeologists can try this. It should be a very interesting project.
Yeah, definitely. Thanks, Davi. Okay, just to make it fair, I'm going to throw this next question to Steve. If we were to define our current era the same way archaeologists define the Stone Age or the Iron Age, what would you call it?
A good question, because, of course, geologists are trying to do that now, right? They're trying to define the Anthropocene. So it's something people are actively discussing. I was thinking about this, and there'd be two ways to do it, right? We could define it in terms of the way we would like to be identified. We would like to think of our era. So that would probably be, we call it the digital age or something like that, right? And then because it's something people think is generally positive and a sort of emblematic of our times, that digital technologies are revolutionizing human communication and information dispersal and so forth. From an so that would be fine. I'm all for that. But from an archaeological perspective or from a geological perspective, like when they're trying to determine how to define the Anthropocene, it's in terms of materials that could be identified all over the world. It's got to be a signal, some kind of information that you could find easily and will be present in many different places. And if that's were the case, I'm afraid we'd have to call this the Plasticine. We'd have to call it the Plastic Age, because if you're, in a few thousand years, if you were to dig up sediments from our time period, whatever else it contained, it'd be full of plastic. And unfortunately, that would be how we would define this age. So we'd like to call it the information age. In the future, it might become the plastic age.
That is a sad thought, but with microplastics being found everywhere, it's
Yeah.
pretty correct. Thanks, Stephen. We got a question directly for Davi. Have you ever encountered a moment when old technology, such as paper, oral stories, or physical tools, worked better than the digital alternatives?
A very interesting question too. Yeah, I most certainly have. Probably everyone has had that too. My technologist side thinks that, okay, so this is a product problem for the digital that we can work on and evolve and improve. Some things are like harder to evolve from. The first thing that came to my mind looking at this question was like, lots of data centers still use magnetic tape actually for backups. So this is actually like the old cassette tapes or the VHS, the same technology we had then. So people still use those for like storing the information that we are not likely to access, and unless in very rare circumstances. So that's one example where technology, computer scientists actually resort to this older technology. But I think this still applies as digital, right? This is not like so. This is too recent for the question, I think. Another thing that comes to my mind is like there's, maybe photography is a good example. A lot of people, there is a whole revival recently with analog cameras. Young people especially are buying lots of analog cameras and taking pictures, and they say, oh, the colors are different. And actually on digital cameras, there's a lot of choices that go into how the sensors process the colors and how the colors are represented on the screen. And some people just look at the paper photos and say, oh, I like this style better. Some professional photographers never evolved to digital. They stuck to analog, to film still today. Closer to my heart, I think I can think of music. And I look at AI generated music today, I still think, nope, we are far from, we still have a long way to go here. So yeah, I still go with analog music on this case. So maybe art is a good example. Maybe that's the pattern that we are seeing, like for human expression, like people have their preferences that are take longer to evolve. That might change in 20 years too. Who knows?
I think that's doubtful. Thank you, Davi. Great answer. Okay.
Could I interject for a second?
Of course, Steve.
Another good example, and this is the discussion that people like archivists and librarians are having now, is that digital technology is great for storing information. You can store a huge amount in a small area, but it's a little bit fragile, and people, as you were saying about the ability to read certain media, disappears over time. And so that you might lose access to this information if all the information that was put on jazz drives, for example, which is a very short-lived kind of disk technology. Nobody can read those anymore, or almost nobody. Whereas we know exactly how long acid-free paper lasts. Things that are on paper are pretty stable, and as long as people can read and turn the pages, it'll be accessible, not widely because it has to be a material object, but so this people are saying this might be still the most stable way of storing information long term.
Yeah, good point, Steve. That was the first thing that popped in my head as well. All our tags in the field are paper and pencils. Okay, for the archaeologists, Vera or Stephen, how do you see new technologies changing how students are trained in archaeology today and going forward?
I can start, and maybe Stephen can give his perspective of a professor. So I think here the question is about recent technologies, right? And maybe this just example what we are doing now. I'm alone in my office, right? And we are talking with you, and I think that's a great example of this diversification. Everyone from the world can actually access a lot of data, a lot of talks, a lot of seminars online. So that I think is really diversifying. It's not just the professor that's locally next to you, but it's the world. So I think that's a really good point. And I think also that, especially in my field in prehistory and Stevens too, we use a lot of archaeological sciences, right? So we use all sorts of things of different disciplines, of geology, of chemistry, of biology, of genetics, to answer questions about the past. And that I think is changing very fast. And really these new technologies are changing not only how we teach, but what kind of questions we can answer. And I think that's very powerful.
Yeah, definitely. And I'm certainly glad for technology to have you guys here today. Thank you. So, a question specifically for Davi. From your perspective, what are the key risks or blind spots archaeologists should watch for when applying AI to their research?
Yeah, that's another tough one. um, so I think one of the major risks when we apply this technology to knowledge tasks is, as we mentioned before, the problem of hallucinations of fabrications. Um, you ask a question and the model comes up with something that is not real, is not part of the data. And I think the modern tools for working with LLMs, they have some very interesting forms of helping solve this problem. Like you can add context to your query, and now these models can handle very large context. So you can give it like maybe a dozen articles, and they ask question about these articles and make relations about these articles. And most of these tools, they allow you to cross-check what they're saying. They actually say, okay, I get this answer from this part of this text, this part from this other text. And I think this is a very healthy use of the technology. Like this, um, again, it helps with grounding. It helps you make sure that you are having a conversation, and they're using the machine to help you make sense of a large amount of information, because it can handle a large context, and it can cross-reference this context among many texts. And sometimes for us, this is harder to do. Specifically for archaeologists, I'd say that we should be very careful with what is on the training data for these models. We really don't know what goes on training these models. Like, it's a very carefully constructed recipe, couple of languages, a mix of languages, a mix of different types of content, and well, what part of this content comes from the corpus of archaeology science as a science. We don't know. I don't know, maybe. And to Steve's point that he mentioned earlier today, like it's like if the model only saw the third-party renderings of the drawings from the caves, and like not really the drawings themselves. And it's so I guess like it's they are very helpful to this, but the principles of doing good science, of like checking your conclusions, checking your what you're publishing, and doing peer reviews also help with that. I think they still apply here, and sticking to the principles of good science are key, even more important now as we use these tools, because they will help us avoid the mistakes that they will make.
Yeah, definitely. Thank you, Davi. Sort of as a follow-up, we got a question. Do you think the growing reliance on AI and LLMs could eventually stifle innovation as individuals or industries become dependent on them? And if so, how would you address or mitigate that risk?
This looks like the quote from Plato we saw a few minutes ago, right? So this, okay, but dual writing makes us our memory weaker. I don't, I disagree with the premise in the question here. Like, I think innovation comes from looking at the problems on the field and looking at the problems that people are having and trying to make their life easier, trying to build products that solve the problems. And I don't think I don't see AI standing in the middle of the process as a stifling, as a blocker to this type of to this very human process of talking to people and seeing what are their challenges, what are their difficulties in their day-to-day operations, and okay, we can make your life easier using these tools here or these other tools here. And I I can see like people coming to discuss with LLMs and like trying to being taken in a very how can I say, oblique direction that's like you go into some rabbit hole of conversation away from the actual problem. Uh, I think we have this today before LLMs as well. Like people learn some new technology and say, "Oh, this technology is going to help me solve this other problem," but we've pretty sure everyone in computer science has been guilty of looking at the new fancy thing and say, "Yo, I'm going to use this for this problem," and it's just not the tool for the problem. And I think maybe it's a similar situation here, like sticking to the basics of how we do innovation, keep talking to people, and no, use AI to process your UX research findings and try to ask them, try to find patterns on the data. Is still a very interesting exercise. Um, yeah, I would stand on this, if this makes sense.
Yeah, thank you, Davi. I would say archaeologists and probably a lot of academics are definitely at fault for using the wrong technology to answer their questions at some point.
Mm.
Our next question is a big one, so I'm going to ask all three of you, because I think you can all contribute. To what extent are we evolutionarily, culturally, and emotionally prepared to cope with the rapid and unstable technological transformations that we live nowadays? Anyone want to tackle that first?
They emotionally, I don't know. You know? No, I think I don't know if we have an answer for that, right? I think being technological apes like we are, this is normal. The difference is not the presence of technology, is the speed of change of this technology, right? So it's this rage. Um, I don't know. I'm a positivist normally, so I have trust that we can do it. It's a different kind of thing. Maybe I at some point will become completely, not technological savvy compared to my son, right? But I don't think that actually is that handicapped at times. I think in some ways maybe, but overall the most important things, the core of what makes us human. Do you need to use the last model of AI? I'm not sure.
Stephen,
Yeah,
how have you adapted to all those multiple telephones over your life? Do you feel like there's been a cultural aspect and evolutionary aspect, an emotional aspect?
Yeah, I'm not qualified to talk about emotions, but I agree with Vera. I think it, in part, it's just simply this is something, again, people have been coping with this for hundreds of years, at least, of really what they perceive as really rapid technological change, maybe thousands if you consider, writing down philosophical ideas 2,400 years ago, a rapid change. But I think in terms of culturally, that is that is something that we have to deal with, but we can deal with it because it's our culture and we can change it. So this notion that all technological change is good, is progress, and the notion that whatever we do, we'll be able to figure out a fix, that might be something we need to revisit. We need to consider seriously as a society. That yes, technology moves us forward in one way, but again, we often give things up. We sacrifice one thing to get a benefit in another area. So we have to be aware of those things, not to say, well, don't worry, we'll just think our way out of this. But then again, technology also helps us to sort of have these discussions. For one thing, it allows us to do things like this. Not that we're going to figure out the world's problems here, but it brings multiple voices and billions of people into the dialogue. It's no longer, 7 guys in powdered wigs in a room deciding the history of the world. In principle, it's 7 billion people deciding this, deciding on the future of the world. And that may help us come up with better solutions. So there are lots of things. I think we can marshal resources that we have to make ourselves more capable of dealing with this.
Ever the tech optimist, Steve. Thank you. Davi, what do you think? Are we emotionally and culturally prepared for the transformations that are coming?
I will go back to the point we discussed before about like how we can adjust the evolution of these technologies, like for our own good, like to keep the parts that we want to keep from our current world. There is this quote, I can't recall now from whom, like humans have had their, like with social media, humans have had their first uh, battle against algorithms and they lost, which is like an interesting view of like we give a lot of data to digital tools today, like as we just browsing the internet, and well, some companies use this all this data to mine information about what are your interests, what you might be interested in it, and they can use this information for any means. Like I think 10 years ago, we've had the case with Cambridge Analytica, where this was used for like political ads that influence an election. And then we had like, this can be used for selling ads. They can be used for just keeping you glued to the screen, like looking at the screen. And there's a lot of work that involves, that goes into how we can better use this information to achieve these goals. And some people see this as like a very adversarial relationship, like how some people actually look at their phones, like their most recent phones, not the third one from the row, as like I need to figure out a way to have a healthy relationship with technology, because uh, sometimes we're losing this battle, and we end up like wasting too much time, wasting maybe health, maybe like giving more information. And so are we culturally prepared for this? I think we, like, if you want to see this as this rapid and unstable technologic transformation as an adversarial relationship, so it can be a tough adversary, definitely. Uh, there are tools that a lot of people use to help with this, um, to control how much trace there are. Also, to the conversations we were having about like, how people influence the evolution of this technology. There are lots of discussions at the government level on how we can control, like put some guardrails around how this information is used, how much they can learn about the user, how much we can learn about the users and use this information. And this is an extremely important discussion. Like if you want to make sure if you're like culturally and emotionally prepared. So maybe the discussion is like how we are like no legally prepared, not legally, but like how can we create these guardrails as a society to make this sure these technologies are like healthy for us and not like kind of adversaries. And this is a very important discussion for us to have as a society.
Yeah, I would agree. And I do think that we learned a little something from the written word since we first started using the written word. So hopefully we'll deal with social media algorithms, AI a bit better. Well, that's about all the time we have. I want to thank our really excellent group of speakers for being here today and all the work that they put into making this dialogues possible. Davi, Stephen, Vera, thank you again for joining us. It's been a pleasure. And I'll just let everyone know we'll be announcing the next season of Dialogues very shortly. So stay tuned to the ICArEHB social media accounts. Those are Twitter, Blue Sky, Instagram. There's too many of them, LinkedIn and Facebook, and you'll see our announcements. We're definitely in the technology here. Thanks again to our speakers and to our audience members. I look forward to seeing you all next time. Thanks.
Thank you, Dialogues team.
Thank you.
Thank you very much.
Sorry, guys, we're done.